Hello students, now we'll take the specific heat of gas. Heat of gas. I have told you the specific heat earlier also. It is the amount of heat required to reach the temperature by 1 degree Celsius of 1 kilogram of the substance. And here also in case of gases we take the same definition. The amount of heat required to raise the temperature by 1 degree Celsius of 1 kg gas is called specific heat. And C is equal to delta Q upon M delta T. M the mass of the gas, delta T rise in temperature, delta Q the heat given to the system. And from here you find that this unit of C will be same as I told you earlier also. This is measured in kilogram, this is kilocalorie or in joule, and this is in kilogram, this is in degree centigrade. So it will have the unit of kilocalorie per kilogram degree centigrade. Unit kilocalorie per kilogram degree centigrade or calorie per gram degree centigrade. Calorie is also taken in joule. Joule per gram degree centigrade. And when the gas, this mass is taken in the form of mole, then this is called the molar specific heat. When mass of gas is taken in moles, the specific heat is called molar specific heat. And you can see from here that here in thermodynamics there are two major changes. One the isothermal and second the adiabatic. In adiabatic change, delta Q equal to 0. Therefore, C equal to 0. In isothermal change, delta T equal to 0. So C equal to infinity. It means that the specific heat of the gas varies from 0 to infinity. Hence, specific heat of gas varies from 0 to infinity. But we know that the gas has three parameters: pressure, volume and temperature. So in every case we have to increase the temperature by 1 degree Celsius. So we can keep either P constant or V constant. Since gas have three parameters: pressure, volume, P, V and T. To increase the temperature we have to keep either P constant or V constant. To increase temperature, either P or V have to be kept constant. It means that the gas can have two specific heat. It means gas can have two specific heats. One specific heat at constant temperature, constant pressure. It is defined as the amount of heat defined as amount of heat required to raise temperature by 1 degree Celsius of 1 mole gas at constant pressure is defined as the amount of heat required to raise the temperature by 1 degree Celsius of 1 mole gas at constant pressure, denoted by Cp. So we have this Cp is equal to delta Q upon delta T at constant pressure. Where here we have taken 1 mole gas So Cp is equal to so much. And number 2, specific heat at constant volume. It is defined as amount of heat required to raise temperature by 1 degree Celsius of 1 mole gas at constant volume, denoted by CV. So CV equal to delta Q upon delta theta upon delta T at constant volume. And you can see that if we apply the first law of thermodynamics, applying first law of thermodynamics, delta Q is equal to du plus delta W. So delta Q is equal to du plus P dV, P delta V. And you can see that at constant pressure, delta Q is equal to Cp into delta T, because we are taking for 1 mole gas. And that you can place to be here. So you can see that this is equal to so much, and at constant volume delta V is equal to 0. Therefore delta Q is equal to du. So delta Q, this is your Cv dt is equal to du. So you can say that this Cv is equal to du upon dt at constant volume. So that means that this specific heat at constant volume is the measurement of internal energy. Thus specific heat at constant volume is measurement of internal energy. So now you can see that the value of Cp is always more than Cv. So now we shall derive another relation which is very important called the Mayer formula. So you like and share this video that tells you about the specific heat of gases. Thank you.